Hey fam, it's your boy Math Man D. Ooh, that was tough. Anyway, we are on the second section of topic 4, which is all about statistics. So we talked about scatter plots previously, and we talked about positive, negative, and no associations, and we're just going to kind of expand upon that today. So we're going to analyze linear associations. We see some nonlinear, one nonlinear problem. But anyway, Angus has a big test coming up. Should he stay up and study or go to bed early the night before the test? Defend your recommendation. Use the graph if needed. So 6 tests over the course of the year or a quarter or whatever. So I went to bed at 9:15, got an 80%, studied until 10:30, got 75%, studied until 11, got 92%, 8:30, got 89, blah, 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 blah. Right? So when I see it like this, I can't really parse the data. So what we're going to do is we're going to see, I'm going to put it on here. If you can look at that data and kind of interpret it, go for it, man. Time to bed, let's say, I guess. And then we'll say score on test as our y values. Okay. Time to bed, let's see what I want to do here. It's going from, let's say 8 till about 11:15. Okay, so let's say this is 8 a.m. or 8, 9. No, let's see. Let's do 8, 8:15, 8:30, 8:45, 9, 9:15, 9:30, 9:45, 10, 10:15, 10:30, 10:45, 11, and then let's see. That's the last one. Okay, so again it goes right. So this sounds a typo. Sorry. So 8:15, 8:30, 8:45, 9, 9:15, 9:30, 9:45, 10. So we're breaking it up into 15-minute increments. Okay. And then for the score on the test, let's see. I think we can actually just do this in terms of 5 points because I think I have 20 here. Let's see. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So let's start doing there. 65, 70, 75, 80. And let's see. What's his lowest score? 75. Okay, so there's a 70 right there, 90s right there, and 100s right there. Okay, so this is in terms of 5, right? But since we don't have anything less than a 75%, we don't actually have to do anything on there as long as we kind of like make it correct up here. Okay, so 9:15 got an 80%. So 9:15 will be right here. We go up and we find 80%, which is right there. That's our first one. Okay, and then 10:30 is 75%. So 10:30 is 75, right about there. 11 is 92. It's right about there. 8:30 got an 89. Right below 90. 10:45 got an 86. Right here. Right there. And then 9 got a 93. So right here. Got a 90. Is that 9? Let's see. 9. 93. So boom. Oh, I guess I should have started that at 8. Whatever. What are you going to do? So if I look at this, right, I see that there's not really any kind of association I can make here because there's not like really a trend line I can draw that goes through it that makes much sense, right? So these are kind of scattered all over the place. So I'd say that this has a no association. Okay, so, right, there is not a relationship between going to bed early or studying late. Let's say going to bed early / studying late, because that's one data point, right? That's your time to bed, right? And the other data point would be, the other data set would be and test score, right? So yeah, as far as I can tell, let's just double check the book. Agrees with me. I guess. Yeah, I mean, so no association. Since that's the case, you can probably just go to bed early, right? It doesn't really matter, so might as well sleep. Because there's no relationship. You might as well get to sleep. Might as well get to sleep. Hope that makes sense right there. All right, since there's really no relationship between them, he can do either one. So he could say I'm studying late or go to bed, but this way he gets to go to bed early and he doesn't have to study. So yeah. Okay, dokie. Example number 1 of linear associations. George and her classmates are measuring their height and arm span. They record their data in a table. Okay. How can they determine what relationship, if any, exists between the two sets of measurements? Right. So we have our thing right here. You'll notice it doesn't start at 0. It starts at 56 for height versus arm span. So student number 1 has very similar height and arm span, 66. Let's see, height is right here. You have 66 versus 64. So that's student 1. Okay. 67 and 65. So right here. Okay. 62 and 64. 64 and 62. 59 and 61. So 59 is right here. 62 and 59. Right there. 65 and 67. So 65. 67 is right there. 64, 66, so 64. 66 is right there. 62, 62. 61 and 62. 58 and 62. 58. 62. Yeah, so how can they determine what relationship, if any, exists between the two sets of measurements? Well, from what I can see, we have a general upward trend. So we can kind of draw a trend line here. Now, the trick with drawing a trend line is you want to kind of get as many points on one side as you have on the other. So try to get an equal amount of dots on one side of the line as you have on the other, right? So let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I would say our trend line is going to go roughly like that. Okay. Maybe I should have put it a little more up, but that's okay. That's a basic general trend line, right? So the relationship that exists, right? We would say it's positive, right? So you would say there is a positive association between people's heights, between students' heights, let's say, and arm spans. Okay, that's that, right? Let's see, strength of linear associations, right? So this is an interesting one. I like definitely the strength of these, or talk about this. The Johanssons own an ice cream shop along the beach. The scatter plot shows their sales by daily high temperatures. They compare their sales by daily high temperatures to the number of beachgoers. Describe the associations below. Well, in each of these, we have a general positive trend line, right? So we can draw a line kind of through here, and we can draw it kind of through there like that. Maybe I should have put that a little lower, but that's okay, right? We have this guy's an outlier, so we're not going to worry about that right there, right? So basically, the hotter it gets, the more people you have that go to the beach, right? Same thing, right? The hotter it gets, the more people buy ice cream, right? So we have general positive trends right here. So this is a positive association. Okay. Right? But your points are more scattered around. So we would want to say that this is a weak association. Okay. So when your points are scattered, right? So we'll say scattered points. Okay, and I'm going to use a different color for the other one. I'm going to say use brown, right? And we can say for beach visitors, it's still a positive association, right? It's a general upward trend for that. And instead of a weak association, we have a strong association, right? You can see our points are much tighter, okay? points are closer together. Okay, so you have a tighter cluster, basically, if you remember the vocab from the other day, right? We have a tighter cluster here versus a looser cluster here. That means it's a weak association for ice cream sales, but a strong association for beach visitors. Right? And that's it right there, okay? So far, we've only dealt with linear associations or associations that form a line, but we can see that while this doesn't form a line, it definitely forms a curve of some sort, right? So we have this right here. So since it forms a curve, right, it is not linear, it is nonlinear. So you would say this plot, scatter plot, shows a non-linear association. And if we were in Algebra 1, we would dive deeper into this and figure out exactly what kind of curve that is. But we're not worried about that. We're just saying whether it's linear or not. So it is a nonlinear association, just like that. Okay? Okay. So take that, put it in your notebook. I'm going to call this 4-2. Go on page 12. What is this? Linear associations? Yeah, analyzing linear associations. Just like that.